In UML, we are talking about sequence diagrams. UML In UML Unified Modeling Language, we have different kinds of diagram. It's not necessary that you use all of them. So it depends on your application, your software you're going to make, or the business modeling you're going to make. The important thing is we can divide in two diagrams: structural diagrams and behavioral diagrams. Structural diagrams and behavioral diagrams. Behavior, it shows the behavior. In this behavioral diagram, we have interaction diagram. In this interaction diagram, we have sequence diagram. So basically, sequence diagram is a behavioral diagram. Its sequence diagram is a behavioral diagram. So it shows what? What are the interactions? What are the operations that are carried out? So we start with an object here. In an object-oriented programming, if you take any object programming, so we make a class and then we have objects. So objects are basically the instantiation of class. So, and the message passing is shown here. Here we have two dimensions. Horizontal means two axes basically. Horizontal and vertical. In horizontal, we show the classes and the objects, basically objects. In vertical line, we show the time. Vertical, the time, and it's not to be scaled. That the time is not very exact. It shows just the duration, that what is coming after what. That this second one will take place after one. And there is message passing. Whenever we take an object, see, object, inside object, what we have? We have functions or variable in an object or in a class. So how do they pass message? How do they interact? That is how the sequence diagram is built. I'll show you an example before I'm going to the notation. This is a hotel system. What all we get in a proper sequence diagram. Let me show you here. It starts from left to right. That is, we have objects. It's not necessary if you're just giving exam for your graduate or undergraduate, don't worry. You just give a name. Otherwise, if you're a software engineer, then you give a proper name of the class and the object name. Now, below this, we have a dotted line. So, this rectangle along with this dotted line is called the lifeline. We call it as a lifeline. Every lifeline, if you see, from left to right. Then, when we have objects, we instantiate an object. For example, constructor, etc. You can instantiate an object. So from starting to end, at what time that object is active, this is called the activation. And this, you see, the length of this activation is different in all these three. Then we message, that is, message passing is done. For basically, we are talking about functions here. Then we have fragments. And these fragments has come after UML 2.0 only. Previously, it was not there. So we have, for a reservation, for example, it's make reservation call. So what will happen? Hotel will ask for the object of this class will ask the function of itself, that whether the hotel room is available or not. So it is calling itself, means calling the function from its artillery, and that is the self message. That is called as the self message. And we have put it in the loop, in a fragment loop, because this is going to run again and again. Every time a client will come or make reservation will come, it's necessary to know how many rooms are available, and that will decide the next course of direction. If you have to give some alternative, so in a fragment, inside a fragment, another fragment is there. So if the room is true, then what do? You are creating a new object. This is a create message. So you can create a lifeline on runtime. This object was not created earlier. It has been created now. And finally, we have the confirmation, etc. Alternative combination, if like kind of thing is there. So if else, looping, branching, all can be kept inside this different fragments. This interaction diagram are dynamic. Class and objects diagrams, they are not dynamic, they are static model views. But interaction diagram, they describe you how the objects are collaborating. So we sometimes show the actors also, which is external to the system. Now let us come to the notation. So we have an actor who is going to act. So if he wants to send some signal or he wants to do certain activity, but first thing first is it's an external to the system. Actor is external to the system. He may be a human being, he may be a system, he may be a hardware. So it's not showing any physical entity, but it's showing particular role of certain entity. So it's showing the role of that entity. A person may play the role of various different actors, several different actors. Or in other words, you can say a given actor may be played by multiple different persons. So these are the two things you need to keep in mind. Actor is external. I'll just tell you, a man can be a father or a child also. He is father of his child, he is child of his father. Like multiple roles. Lifeline, here we have a box here, and then we have these dot lines, and these are the lifeline. And here we have activation. Under the lifeline, these dotted lines, they have a very small rectangle vertically. And this point shows that the object is activated here, right? Object is working down here. So only this activation shows what time period it is active. Call message means if message has to be passed from one to another lifeline. And when you send a message, you might want some reply. So that is a reply message. The self message, as I said, the objects have different functions. Now you are invocating, because object has multiple functions, a class have multiple functions. So a lifeline, that particular class is accessing, or the object is accessing its own function. That is called the self message. Now coming to a recursive message. Now a function is there. In a class, there is a function called factorial or a Fibonacci. Now in order to fulfill factorial or Fibo, we can use the recursive message. So fact will call fact itself. Fibo will call Fibo itself. So that is a recursive. You see, just a small box is there, which is added to self message to make it as a recursive message. It is calling itself. Create message. Now what will happen? As I said, we have already defined that these are our lifelines, these are our objects, these are class. But it is fixed. What does that mean? Are we not able to create any object? Yes, we are. So we can create object at any time. That is, we are going to create another lifeline. So this is a create one. And when we have a lifeline, we don't need it. An object is not required here, which we created. So you can destroy message also. This destroy message is going to destroy or remove this object. Duration message. It's simply a slanted kind of arrow. So a message is like this, but a slanted message is, this is the duration. This is the time, 2 time instant. Just to show the 2 time instance between the message invocation. Note means you are trying to give some remarks, some metadata or certain information for the user to know, or to yourself be knowing after you visit after some time. So there is a flipped rectangle. So message and focus of control, we have discussed about how the message we are dealing with arrow. So in all the left lines which you see, they are going to interact, because basically it's an interaction diagram. It's a message from one lifeline to another, one object or one class to another. Class are collaborating, they are showing collaboration. So message start event, then coming to the message start for the second one, then it ends, the second lifeline will end, and then whenever the return message will come, that is the end of the first lifeline message. So every time the focus of control is changed, depending upon the message, how this message is starting from one point, going to another point, coming back like this. Sequence fragments, as I earlier mentioned, UML 2.0 has introduced a sequence fragment, which makes the sequence diagram quite easier to understand, to create, to maintain. So we make a box, we call it as a combined fragment, and say here there is a box, we specify here this box is called as a sequence fragment box. Here we have a small box which will put certain content which shows what type of fragment it is: ref, assert, loop, break, alt, opt, neg. If you put alt, what does it mean? It means alternative, like if else. Only the one whose condition is true will execute. For example, switch case construct. So if you put switch, there are multiple cases, but whichever is true is going to work. That is the ALT. So this is ALT you are going to write. If you write OPT, ALT and OPT are almost similar, and this optional fragment execute only if the supplied condition is true. So equivalent is to an alt is only, that is, one trace will be there. Parallel means each fragment is running in parallel, simultaneously. Loop is already there if you want to run this fragment multiple times. So we will have a guard condition, because every loop has some guard condition or some conditions to start and to end. Then we have region, that is only one thread is allowed to work or execute, critical region. Neg means negative. The fragment shows an invalid interaction. So if this interaction is happening, we just want it to be shown invalid. Ref is the reference. So it refers to an interaction defined on another program. So the frame is drawn to cover the lifeline involved in the interaction. So you can define the parameters and a return value. Now you have SD. All these sequence diagram can put in one sequence, in one fragment, SD. So here is a combined fragment example. So we wanted to show how this fragment can be placed. So if you go to some Amazon or Flipkart, you start what? You start order. Then the order is being done. That dispatch process is started. So now this dispatch is the dispatcher will dispatch. Now the dispatcher, there are two kind of distributor we are discussing. One is very good, very careful. One is normal, moderate. So we put it in the loop. We put this into loop, and inside this ALT we have condition if else. That is, if this product is greater than 15,000, that is, it is of importance, then we'll only send it to the careful, the best distributor. If it is below that, then we'll have else. So this is a guard condition. It's a guard condition, and ALT is the operator, fragment operator. Else, see, one time you send to the careful if the amount is greater, otherwise you send it to the regular. It depends on the situation. That is why we use the alt, guarding condition, and then it depends. So there is a dotted line also in between in this alt. So this is called frame. We call it as a fragment or a frame. Now OPT is also there. OPT is that if you need confirmation, it's okay. If there is a messenger, you want some message to confirm it, that you say the item is delivered or the distributor has given you the message. If it is required, it is okay. If you don't require, it is okay. So OPT is optional. So option is there. Now I'll tell you how we can, because actual thing is use case. We start with use case, then we go to the activity diagram, then we go to the sequence diagram. So you see use case, then we make the activity, then we go to sequence. So user requirement are captured in these scenarios, and this scenario is the basic building block of the design modeling of the actual software. So how this use case can be represented, converted and understood in the form of a sequence diagram, let's see that. So you'll understand it better, that how we start. So this use case is the specification of a sequence of action including variants that a system can perform interacting with actors of the system. So here you see there is a use case, very simple use case, which is search book. This use case is search book. Now if you see the right hand side is the sequence diagram. So how do we convert or how do we relate the use case with the sequence? So first thing first is the customer. Now he is a user. It's something which is external to the system. Customer, he is an actor. Now on search. So main scenario here is the customer specifies an author on the search page and presses the search button. So user will do something search, and whatever search is going to, first we have to validate the search. That is, system validate the customer search criteria. Is it correct or not? So the search page class is going to call its, or the object is going to call itself. Its solve function validate search. If the author is entered, the system searches the catalog for books associated with the specified say author. User has put some Jack Daniels or some name, Shobha Day, whatever given. So now the search by author, if he has given that, if it is done by the author, when the search is complete, the system displays the search result on the search page result. So there is a catalog, there is a creation of search result, and the display will be shown. But if he has done using author, but now there is an alternate path. Now if the user hasn't used the author name, then what? He has not given that Shobha Day name or some Ruskin Bond name. Then what will happen? There has to be an alt. That is why we have used a fragment here. If the customer did not enter the name of the author before pressing the search button, the system displays an error message. So here this error message is already in the search page class. So this is how it is shown. Just to give you an idea how use case can be related or converted or shown in a form sequence. So I'll just give you an example, and this example is very basic example. You have a mobile or a computer. What do? You open an app. When you open an app, there are certain background activity take place. So if you are, say, a some user, now you want to run an application. There is a launcher. App will launch. There will be some starter for the application, and there will be some bootstrap work like the memory requirement, like the say processor requirement. All this is going to do. So launcher we have. This is a launcher app, which whenever you click, there has to be some launch activity. Then the app started, you will see some screen, there's something is starting. It will take certain time, some splash screen will be there. Then we have the bootstrapper that is going to check for all the background hardware interactions, etc. So what I'm trying to suggest is we have a user. It's a user. So who is going to start this app? It can be any app. Okay. So now the launching of app is the app will start. So there are, first of all, you have to show all these three dotted lines to show that we have three lifelines, 1, 2, 3. Now you see that user is running the application. He wants to run the application. He may use mouse or he may use his hand. Now the application will start. See, the launcher will try to start the application. So now it will go to app starter. It will go to app starter. Now what will happen here? There will be some splash screen. The first screen which comes whenever an app is run. This will come, some round circle, etc. Then this will run, this will go. Now the bootstrapper, now the background activity, hardware configurations. Every app needs some memory, some cache, etc. So there will some initialization. You can call it anything, Unity container or whatever you think. It's just something is going back. That is, it may create a shell. It may initialize certain modules. It can be hardware modules. It can be software modules. So all these had to be done. Whenever you open a system, what will happen? Black screen, BIOS. It will check for your hard drive, for your RAM. Everything has been checked. So this is the bootstrapper thing going on. And now this whatever it has created, it will show, and then because that splash screen is there only because all background activity is done. Then this splash screen will be done, and then you'll get all the information which you want to interact. So this is how it is going to work. So this is just a very basic thing I wanted to suggest you. So this is all about this sequence diagram. Thank you so much. Take care of yourself.